Okay, this is the Miller Syncrowave. It's the TIG welder currently in the shop. The way to get started with this machine is, let's talk a little bit about the parts and pieces here. We have the ground clamp. This is similar to every welding process, just like the MIG. Also, cutting processes like the plasma cutter, for instance. So what we want to do is make sure this is on the table, therefore it's grounded at this point. If that's not attached to the table, you can try to weld, but it won't. Nothing will happen. The next thing is the actual torch itself. We can talk a little bit about the inner workings, but most people have already had that lecture. We'll just be concerned for on how to swap out the tungsten. You basically loosen the back part of this. That reduces pressure on the collet, allows you to slide in and out the tungsten, so you can just take it out just like that. Sometimes it gives you a little bit of resistance, but that's okay. And then you put it back in, and the idea is here that you want it to stick out this way from the edge of the lens cup, about the radius of that lens cup. And that's a good starting point. It's not a scientific measurement by any means, it's just kind of eyeball it. And you tighten this down. That applies pressure to the back of that the sleeve, and then now the tungsten won't fall out. Okay. Let's see here. All right. The next piece here is the control pedal, and this is stored over on the side of the machine. And that will just simply be, the amperage pedal will be just on the floor, and we'll talk about that in a second. Okay. So we haven't turned the machine on yet. The reason we're going to talk about this first before powering up the machine is that it's crucial that this is not moved to any other position while the machine is on. It needs to be off. That's the important takeaway here. Currently, and most of the welding will be mild steel or stainless steel or aluminum. Those three processes. The mild steel and stainless steel is going to be electronegative. Okay. If you're going to weld aluminum with the machine off, you turn it to AC. Okay. Now this is DC, direct current, and this is AC, alternating current. If for people that are new to this, just remember aluminum, and that's a good way to remember it. But we're going to go ahead and have it set over here to DC because we're going to weld mild steel today. Anyway, at this point, now we can go ahead and turn on the machine. It's your on button. Machine's on. It goes through its boot up screen. And it will remember the last amperage setting from before. For this little seminar, we were welding thin gauge tube steel, and to be honest with you, the settings that I like for that are about 47 amps. You can have the pedal all the way down at 47 amps, and you shouldn't blow through. If you have good clean steel, you shouldn't blow through the tube with that. And this is something that you just have to experiment with. You're not going to ever just open a book and say, well, it has to be this amount of amps. Just play with it. And the reason that is, it's a moving target. Your pedal throttles between 0 and 47 amps on this. So if your pedal's all the way down, you get 47 amps. If it's barely on, if your pedal's barely down, you're going to get a fraction. Okay. So for mild steel, you just want this one green light that says TIG. Okay. All these other functions are a little bit more advanced. Dig, for instance, is if you have your stick weld. So if that's on, you can actuate dig. There's no point to use the stick welding function on this machine because it's a messy process and you shouldn't do it inside anyway. And this machine should stay inside. So we're going to go back to TIG, and you'll notice that you can't. It says not valid. You can't use it. So balance is if you're AC welding. And that controls the cleaning action of AC welding. And I'm not going to go into it now, but go to weldingtipsandtricks.com and you can learn more about AC welding there. And you'll hear a lot about balance. Over here is you have an option for pulse per second welding or pulse welding. And what this does is it sort of throttles the amperage so that you don't have to move your foot. It'll turn on and off machine however many, up to 10 or up to 15 pulses per second, I believe. Pulse per second, you can go up to 15. You don't need to worry about this unless you're welding super thin sheet metal. And that's where this comes in handy. And again, go to weldingtipsandtricks.com to find out more info there. It's a website or a YouTube channel that I've found lots of good information on. That gentleman really knows what he's talking about. Anyway, so yeah, I'm going to turn that off. So really the only light for this machine that we need to be worried about for this studio is going to be making sure the TIG light is on for mild steel. Okay, so this is, again, adjusts your amperage, how much heat you're going to put in the part. So we'll keep it around 47. This button right here, if you hold it down, you'll purge the atmosphere out of the torch. So try to be quiet so when I hit this, you can hear it. So I'm going to turn this on right now. The gas is now on, so if I were to hit this button, you can hear it. It's just purging the lines. So now there's nothing but argon in this. Okay, so we need to talk about what a good cubic feet per hour setting is on the argon. I like to do around 35, so that the top of the ball when it's floating is 35. So how do you get the thing to float without having the pedal down? You hold down again the little button beneath that says A on it, and you can hold that down. You can see that ball start to float, and you can adjust this right here. 35 seems to work real well. Some people might say it's probably excess. You can try to turn it down and see if you can get away with it. You can try to say go to 20 and see if you have oxygen or atmosphere in your weld puddle. But 35 will make sure that you don't have that. That's not an issue. Okay.
How do you tell when the tank is empty?
You can tell when the tank is empty because when you're welding, you'll get a really moonscape-like weld puddle. It'll be very porous, and you can see all the little craters in it, and it makes a lot of sparks, and your tungsten will burn up. It'll be super obvious because you're used to welding and everything looks great, and then all of a sudden the scenario changes and the environment changes, and you come over here and you look on this gauge, and this black needle will be all the way bottom down. So that's how you can tell. All right, let's see. What else do you want to cover with this, Michael? That's about it? Okay. All right.